We're trying to find the dy dx derivative if y is equal to e to the x times tangent of x. So basically, y is equal to this function x times tangent of x plugged into this function e to the x. So we can write y as f of g of x, where now let's be careful and think about which of these should go where. In this pattern, f of x is what we call the outer function, and g of x is what we call the inner function. So the question is, we have x tan x as one function and e to the something as the other. Which one is being plugged into which other one? The inner function is x tan x, and the outer function is e to the x. Now the chain rule pattern says that y prime will be equal to f prime of g of x times g prime of x. So I'm going to need f prime of x, which we know is just e to the x. And I'm also going to need f prime of g of x, which is e to the g of x, which is e to the x tan x. Now I'm not done, because I've gotten this f prime of g of x piece, but I'm also going to need this g prime of x. Let's calculate g prime of x. And here's the tricky part. Here's what makes this question challenging. When I go to calculate g prime of x, I actually need product rule because I have something times something else. So in the process of calculating this chain rule, I run into a situation where now I need product rule. A times b for my original would be a is equal to x and b is equal to tan x. A prime is equal to 1. And b prime is equal to secant squared of x. And I do my a prime b plus ab prime pattern, and g prime of x is equal to 1 times tan of x plus x times secant squared of x. So this whole thing is my g prime of x. Now, I'm just going to go and plug in the pieces where they go. I have both pieces that I need. So y prime is equal to e to the x tan x, because that was my f prime of g of x piece. You got to be careful that there's so tan x times x secant squared x. This would be my final answer. It's not easy because once I start taking the derivative, I then run into a situation where I have to take the derivative again using a different rule.